Alright, hello again, Year 9. Okay, so in this video I'm going to talk you through the difference between series and parallel circuits. Okay, so in a series circuit there's only one path for the electricity to flow through. So if you look on here, this is a series circuit. The electricity has only got one path that it can follow around the circuit. In a parallel circuit there are branches and different paths for the electricity to follow. So if you look here, once you get to the junction, the electricity can flow this way or it can flow this way. Okay, so that's the difference between the two different circuits. Now, parallel circuits can have lots of branches, they don't just have to have two. Okay, now in terms of, oops, that went a bit more quicker than I thought. In terms of the batteries or the cells, they provide the push behind the electric current. They're what make the current flow. Okay, so the more cells that you've got in a battery, then the more voltage that you've got, the more push you've got. So in this case, one cell has got a voltage of 1.5. So if I increase the number of cells, then it would be 1.5 plus 1.5, which will give me a total of 3 volts. And then if I added a third one, then it would be 3 lots of 1.5, which would give me a total of 4.5 volts. So that gives me more energy behind my electricity. Okay, so if you're measuring current in a circuit, then you need to use an ammeter, and you have to put it in series with the rest of the circuit. So that means that you have to make a gap to put it into. So if I'd made a circuit in this case with just a bulb, I'd have to undo one of the wires, take it out, make a gap for the ammeter to fit in, so that the current has to flow through the ammeter in order to measure it. Now, a voltmeter, you actually have to apply in parallel to your circuit, okay, or parallel to your component. So in this case, you'd set up the circuit without it, and then you use the wires to put it on either side. So what this will do is it will measure the energy difference between the amount of energy going into this component here and then the energy coming out, and this measures the difference. So sometimes you see voltage referred to as potential difference, okay, but that is in parallel to the bulb. Right, in terms of having a little play with the simulation, okay, I know it's not as much fun as real circuits, but we're going to have to make do, okay. So the first thing that we can do is that we can actually increase the number of cells. So if I turn my bulb on here, you can see that it lights up. If I increase the number of cells, and don't forget I'm increasing the voltage, if I turn it on, then my bulb is going to get brighter. Okay, I'll let you see the pattern with the 3 cells. Now I'm going to leave it on 2 for the time being. The other thing that I can do is that I can change the number of bulbs. Okay, now if I increase the number of bulbs to 2 and turn it back on again, what you'll notice is that this time they're not shining quite as brightly. And if I put the voltmeter on here, the reason becomes clear. So I've got a total of 4 volts from my battery, okay, but each of those bulbs is only receiving 2 volts of energy. If I did it with one bulb, then that one bulb gets the full 4 volts of energy. Okay, so that's why it's brighter. If I increase the number of bulbs to 2, then it's having to share that energy between them. Okay, if I increase it to 3, it's having to share it even more, in which case they're not as bright, they're even dimmer, okay, because they're sharing that energy between them. Okay, so I'm just going to switch my voltmeters off. Okay, I'm going to go back to one bulb, and I'm going to try it with the current. Okay, so in this case, if I try it with my current, measure it on either side of the bulb, it's 0.6. Okay, so the current is the same on both sides of the bulb. Now if I increase the number of bulbs, okay, and turn it back on again, there is slightly less current because it's getting slowed down by the bulbs. But what you'll notice is that again, at each point in the circuit, the current is exactly the same. And the same if I go up to 3 bulbs. First of all, think about what you think will happen to the current. Is it going to be bigger, smaller, or is it going to stay the same? And then it will also be the same at each point. So you'll notice it's gone down because it's having to go through 3 bulbs this time, so it's slowing it down even more, and it's the same at each point. Okay, so important things to remember: in a series circuit, the current is the same at each point. Okay, so wherever I put my ammeter in a series circuit, the current is exactly the same. So I've got 3 points here. At this point it's 1 amp, so at this point it's also 1 amp, and at this point it's also 1 amp. It doesn't matter where you put it, okay, the current is going to be exactly the same. So that's what you're going to think about on these 2 exercises. So you've got 3 ammeters that are labelled 1, 2 and 3. You've got the ammeter reading at number 1, which is 3.4. So you have to tell me what the ammeter reading is going to be at number 2 and number 3. Okay. Now, in terms of the voltage in a circuit, like we showed on the simulation, the voltage has to get shared between the bulbs. So in this case, I've got a total of 6 volts coming out of my battery, and it's shared across 2 bulbs. That means they get half each, provided they're the same type of bulb, which means they both get 3 volts. If there was only 1 bulb, think about what the voltage would be across that 1 bulb. Also, you could think about what would happen if we added a 3rd bulb. What would happen to the volt reading for each of those if there was 3 bulbs? Okay, so this exercise asks you to do the same idea. So you've got the voltmeter, which is the total across the battery, and then it's being shared by the 2 bulbs. So you just have to think about this number, okay, and think about how you can share it between the 2 bulbs. And that's the same idea for this one too. Okay, now in parallel circuits, you've got a slightly different pattern. I've gone all out of focus for some weird reason. Excuse me. Right, hang on. There we go. Okay, so again, you can investigate the parallel circuits. So this time I've got 2 cells. Okay, in this case I've got 1 bulb, so this is behaving like a series circuit. Okay, so this will light. Now this time, if I increase the bulbs, then I'm going to have another branch. Okay, now I want you to have a little play with this and see if you can come up with patterns of what happens when you increase the number of cells, when you increase the number of bulbs, and what happens with the current and the voltage in different parts of the circuit. Okay, so pause the video and have a little play. Okay, so in a parallel circuit, this time what happens is, because there's branches, the current will get split between the branches. So if you look on this side here, the current is 2 amps. As it gets to here, some of that electricity will flow through here, which will give it 1 amp. Some of the electricity will flow through here, which will be another amp. And then when they get round to here, they join back together again and it becomes 2 amps. So in a parallel circuit, the current is split between the branches. Voltage is different in a parallel circuit. Each branch will take off the same voltage as what's available in the battery. Okay, so in this case, I've got 6 volts available in my battery here. The first branch will take off 6 volts. The second branch will also take off 6 volts. If I had a third branch, that would also take off 6 volts. Now the difference with this is that because they're taking off the same amount of energy, each of those bulbs will be the same brightness. They will not get dimmer, okay, which is certainly a benefit of parallel circuits. Okay, so you can now complete the tasks that you've been set on class charts.